sac222 problem number 3 is an interference problem. We've got light of a specific wavelength incident on what's referred to as a diffraction grating. A diffraction grating would more properly be referred to as an interference grating because the phenomenon under consideration here is interference rather than diffraction. So light passing through one slit interferes on the other side of the grating with light passing through other slits. Here I'm schematically representing some incoming light. Here's a line to represent what I mean by the straight ahead direction. I will put a screen up here. It's not necessary that we have one. The interference occurs whether there's a screen there or not, but it's easier for us to see. We'll have a central maximum bright spot. There's the first order, second order, and third order. The zeroth bright spot is interference order 0, and there's first order, second order, third order. And where this maximum occurs, the angle at which that maximum occurs is what we're being asked about. We're supposed to find theta given the wavelength and given information about that diffraction grating. Wherever you've got an interference problem, you need the spacing between adjacent slits. Call it D. And D is going to be the number of centimeters per line. That's the distance between adjacent slits. Therefore, it's 1 over the number of lines per distance, which is what we're given. So it's 1 over the number of lines is 65, given to 2 sig figs, lines per centimeter. And I'm going to put that down as 1 times 10 to the minus 2 meters, but that should not be taken as 1 sig fig. This is an exact integer value, the 1. And if you evaluate that, you get 1.54 times 10 to the minus 4th when it's rounded off to 3 sig figs. 1.54 times 10 to the minus 4th meters. For D. Now, the formula that characterizes interference is m lambda is equal to d sine of theta. D sine of theta represents the path difference for light that travels through one slit to get to the point in question versus light that travels along through another slit to get to the point in question. Light, in one case, has to travel farther to get to the same point, and how much farther is what we call the path difference, and that's d times the sine of theta, if you work it out. And if that path difference is an integer number of wavelengths, then you get constructive interference. And in fact, we're asked about third order interference, so we're asked about the case where that integer m is 3. The m represents the order of the interference. So we're supposed to find theta. Let's solve for sine of theta first by dividing both sides by d, and then switching sides at the same time. And then we'll take the arc sine of both sides. So theta is equal to the arc sine of m lambda over d. That's sine to the minus 1 is their notation for the arc sine. Note, if m lambda over d turns out to be greater than 1, you can't take the arc sine of a number greater than 1, because when you got to take the arc sine of something, what you're going to do is to find out what angle there is that you would take the sine of in order to get this value. And when you take the sine of an angle, you always get something between -1 and 1. So if this value is greater than 1, there is no solution. There is no arcsine to it, and we would say third order maximum doesn't occur. Let's check that out. In this case, we got theta is equal to the arcsine of 3 times the wavelength was given as 619 nanometers, or 619 times 10 to the -9th meters. And then I'll divide that by that slit separation that we just found. That's 1.54 times 10 to the -4th meters. And this turns out to be a very small number, 10 to the -9th up top and 10 to the -4th on the bottom. So there's no problem at all in taking the arcsine of it. And indeed, the angle itself is small. Rounded to 2 sig figs, theta turns out to be 0.69 degrees. Now, when you get a big slit spacing compared to the wavelength, let's see, this is 619 times 10 to the -9th. This would be 154,000 times 10 to the -9th, and that's huge compared to the 619 times 10 to the -9th. So we've got that case where you've got a big slit spacing. The diffraction pattern is very closely packed. That third order one is only out there at an angle less than a degree, and the first and second order maxima are even closer to the central maximum than that. So that wraps it up for essay